and gentlemen. So we have find the center, vertices, foci, and eccentricity of the breadth. All right. So to do all this, we know we need to figure out A, B, C, right? We don't really need B unless we need to figure out A and C. And we need to find H and K. Well, the only thing we've learned how to do that, ladies and gentlemen, is when we had it in our standard form. Is this in our standard form? No. No, right? We always had x minus h squared divided by either a or b plus y minus k squared divided by either a or b and then equal to 1. So what we have to do is write this in that format. Once we have it in the format, is it much easier to find a and b? Yeah, because a and b are what your denominators are. And then we can use the formula to find c, and then we already know what h and k are. So, one thing I noticed about that standard form is I had the x plus the y, right? X plus the y. It was x minus h squared, and then plus y minus k squared. So what I'm going to first do is let's group the x's and the y's. And then I'll get that constant over there. So I have 4x squared minus 8x plus y squared plus 4y, and let's add the 8 to the other side. Okay? Now, looks a little bit closer. We have the x's, we have the y's, and we have an 8. However, that wasn't the formula, right? It was supposed to be x minus a number. So I need to get this x minus h squared. I need these x's to look like this, right? This to look like that, correct? Right, and the only way we can do that is what this is remember, this is a binomial squared. A binomial squared. The only way we get a binomial squared is when we factor a perfect square trinomial. So I need to take this and make it a perfect square trinomial. And the only way that we've learned how to make a binomial into a perfect square trinomial is by completing the square. Completing the square. So to do that, let's take it. So we have 4x squared minus 8x. I need to complete the square. I need to make this a perfect square trinomial. Remember, the first step in completing the square is you cannot have a coefficient of anything besides 1 in front of your quadratic term. So the first thing I do is I factor out a 4. Right? Then, remember, we do our special little case in doing b divided by 2
Why don't you
and square it. Huh?
Why don't you can't you pull out an x?
You can, but remember, we want to keep this as a quadratic. You could factor out an x, right? But if you factor out an x, then you're not going to, remember, our whole purpose of completing the square is not to factor it, but to create a perfect square trinomial that's quadratic, right? So we do b divided by 2, which is, and then I do negative 2 divided by 2, squared, which equals negative 1, which is 1, right?
Yeah.
So I have 4 times x squared minus 2x plus 1. So let's write that in there. 4 times x squared minus 2x plus 1. But now, ladies and gentlemen, remember, whatever we do on one side, we always have to do on the other side, right? Now, what did I do? What did I actually add to this right side?
4.
4, right? Because I added a 1. So from here to here, I added a 1, but that 1 is being multiplied by 4. So over here, I'm also going to have to make sure I add 4. Right?
What?
Do you understand from this step to this step, what's the only difference? I added a 1, right? Well, this is factored down to a trinomial, but I added a 1. Okay? And by adding that 1, but that 1 is being multiplied by 4 outside the parentheses.
Oh.
So therefore I need to multiply it over here. Now let's go and do the other one. The other one is y minus k squared. Well, in this example, I have y squared minus 4y. I need to create this to be a perfect square trinomial. So I do negative 4 divided by 2 squared, which equals 4. So now I'm just going to add 4 to both sides.
Wait, why is it negative 4? I mean, I know it doesn't really matter. But
Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4.
where did you get negative
I don't know. I
Right
rewrote it
there.
wrong.
4?
Oh, I just wrote y minus k. You're right, it's positive 4.
I didn't think it mattered. It's a little confusing.
So therefore, this, as a perfect square trinomial, is y squared plus 4y plus 4. Now, I'll keep these in parentheses, because now I added 4, so I have to add another 4, right? Yes? Okay. So now, why do we complete the square again? Why do we care that these are perfect square trinomials? The reason why we like perfect square trinomials, and the reason why we have to complete the square to create perfect square trinomials, is because when we factor these, when I factor this, it creates a binomial square. When I factor this, because I completed the square to make it a perfect square trinomial, its factored form is a binomial square. So let's go and factor them to their binomial square. So we're almost there, right? Not looking too bad. However, we don't have an A and or B, and we don't have it equal to 1. So, to make this equal to 1, I can divide by 16, right? So we know now this, that goes to 1. This is just going to remain the same, y plus 2 squared over 16, plus this reduces down to 1/4. Okay, so almost there. All right, so now, ladies and gentlemen, we have it. So we went from this to this, right? This to this. Now, since it's in this form, they said find the center. Can we easily find the center? The center is?
-1, 2.
Close. Remember, it's
Oh, yeah,
opposite
yeah.
of h, opposite of k, so the center is?
2, 1. 1, -2.
Right.
Ah,
1, -2. If you just keep on yelling out, you'll get it. But yeah, just remember it's the opposite of h and k, okay? And remember, x is in the ellipses. X is always going to be with your h. Same thing with parabolas, right? Yes. Good. Yes. Okay. Good. So we have center equals 1, -2. Then they say find the vertices. Well, ladies and gentlemen, the vertices are how far away from the center?
2, A. 2. I don't know. I really don't. 2. What you just
A.
say?
A. Okay. Let's stop. Let's take a break here. First thing we need to do before we even start talking about vertices and foci, let's look at this graph. Is this graph going to be
Vertical.
horizontal or vertical?
Vertical.
Vertical, because our larger term, which is our a squared, is under the y squared, right? So let's go and plot a graph of this real quick. Doesn't need to be pretty. So now we know, since it's a vertical, because my a squared is under my y, I know that I have foci and vertices. Now, we said the center is at 1, -2. Let's go and determine what the vertices are. Now remember, this distance from the center to a vertice has a distance of a. And we're saying that a squared, remember a squared is always your larger, right? Because if this is a and that's b, right? So what we're saying is your a squared, that's your larger one, and since that's under the y, that's what's made it vertical. So if I'm saying that 16 equals a squared, what is a?
4.
4, very good. Plus or minus 4 though, right? Because notice, look at my center. I have to add 4 and I have to subtract 4, right? To get to my two vertices, I have to add and subtract, so it's plus or minus 4. Now, am I plus or minusing that to the h value or the k value of my vertex? The x or the y, as you could say. The y coordinate, right, which is your k. So therefore, my center, 1 is going to remain the same, but it's going to be -2 plus or minus 4. Does that make sense?
No, it really doesn't.
The 1 remains the same. The center, the x value remains the same. They're all on the major axis. What's your question?
I don't understand. Just keep going.
What, you
She
got a
wasn't here
question?
last. I wasn't here last class.
Okay.
I
So she doesn't know that.
We can go back through it. So therefore, we have our center is officially going to be at, I'm sorry, your what am I rewriting?
Yeah, that's what.
No wonder you're not making sense.
You don't know what you're doing?
Right in the centers. So your vertices are going to be at 1 comma, 1 comma 2, and
1 comma -6.
1 comma -6. How about I just write everything is labeled as center, and then, then you guys can just guess what it
Whatever
is.
you do is fine, we don't care.
So therefore, your vertices, you have 2 vertices, right? Your vertices is 1 comma 2 and 1 comma -6. Notice how they all have, your center and your vertices all have the same x coordinate, right? Because they all lie on the major axis. Last thing we need to do is find the foci. Well, ladies and gentlemen, foci has a distance of c. And we got a little issue with that because do we have a c in this formula? No, but the only thing we do know is a squared equals b squared plus c squared, right? And do we know what a and b are? Yes. A is 16 equals 4 plus c squared. So by doing a little bit of work, we could say c squared equals 12. Take the root of both sides. And I could say c equals the square root of 12. We can reduce that down to 2 radical 3.
Must we?
Huh?
Must we?
Yes. Okay, so I'll finish my work over here. So we have the center of the vertices. Now to find the foci. The foci is the foci gonna have the exact same x coordinate as the center and the vertices?
Yes.
Yeah, so we know it's gonna be 1, right? 1 comma plus or minus
2 comma.
the vertice or the center, which is -2. -2 plus or minus, what's my value of c?
2 square root of
2 square root of 3. Now, can we add a 2 square root of 3 to a -2?
3. No.
No. So we can just write our foci as 1 comma -2 plus 2 square root of 3, and our other foci is 1 comma -2 minus 2 square root of 3. Do not give me decimal form. Leave this in the exact form. All right? So now we have our foci, center, and our vertices. Now, I did say we'll do eccentricity. Let's just try to write it real quick. So the eccentricity, guys, remember, is a ratio of c divided by a. So just take your c, which is, I don't remember where it is, 2 divided by square root of 3, divided by your a, which is
4.
4. And there's your eccentricity. And obviously, remember, as we talked about that, as that gets closer to 1, that's, you can see how that's going to be spread out. As it closer to 0, that's the closer it's going to get into a circle. Okay? It's a lot. But is there any major kind of questions of uncertainty that you guys maybe have?